Welcome back, AP Statistics. This is Chapter 23, Part 2. We're going to be performing a two-sample t-test for a difference of means. So in our last video, we found two-sample t-intervals for a difference of means. Now we're doing the two-sample t-test. So here we go. To the right are results of an experiment to determine whether someone who wanted to buy a camera would offer a different price when buying from a friend as opposed to a stranger. So here's how the experiment worked. So you have all of these subjects over here, and some of them were at random asked if someone were offering a price for a used camera and they were buying from a friend. What price would they give for a particular camera? And those are our data values on the left. But alternatively, other folks who were selected at random were asked, okay, suppose you were offering a price for a used camera, but you were buying it from a stranger. So they have a particular camera. Don't know what camera it is, but it was the same camera for each of these participants. But for the second group, they switched it up and said, you're buying it from a stranger. What price would you give? And the goal of the experiment is to determine whether the price changes depending on whether the subject was assuming they're buying from a friend as opposed to buying from a stranger. That is an experiment, and that is going to influence how we check our assumptions and conditions on the next slide. So, is there a significant difference between price and offer made to a friend as opposed to a stranger? Let's get to it. Here's how the book lays out the hypotheses. The difference in mean price offered to friends and the mean price offered to strangers is 0 is the null hypothesis. So the difference of mu sub f, that's the mean price offered to friends, and mu sub s, the mean price offered to strangers, is 0. Alternatively, we could have mu sub f equals mu sub s if we just add a mu sub s to both sides. Little algebra could do that. That is another and frankly more common way to represent the null hypothesis. I'm personally a fan of this representation. I think this is more true to mathematically what we're doing. We're trying to see if our difference is equal to 0, or, alternative hypothesis, if the difference is not equal to 0. The difference in mean prices is not 0. So let's check assumptions and conditions. So we have independent groups assumption, just like for t-intervals. We have to check for independent groups. Randomizing the experiment gives independent groups, all right? Since we have sorted people into this group and that group at random, the groups are not influential to each other. We can make that assumption there. So independence within groups, that independence assumption is the second one here. And that is not a huge deal since this is an experiment. So what matters is that people were sorted into these two groups at random, okay? We don't need to randomly select from the population. So, randomization condition, the experiment was randomized. Subjects were assigned to groups at random. So basically the same idea as the independent groups assumption applies to the randomization condition. And the nearly normal condition, this is definitely the most sus condition of the group because over here is our first histogram, and I guess that's good enough. I guess that's unimodal and symmetric. I feel guilty saying that's unimodal and symmetric, but the show must go on? Okay. Buying from a stranger, okay, that's at least unimodal and makes a vague attempt at being symmetric. Okay, we got a height of 2 over here, we got 2 heights of 1 over here. This is definitely in the category of good enough. And you know what? Whatever, the show must go on for the buying from a friend histogram. So whatever, here we go. Let's crack our knuckles and take care of this. We're going to use the two-sample t-test. For pooled, of course, we choose no. All right? Let's get to the calculator and get to work. So we are here at the calculator. I have entered in the values in edit, so you don't have to watch me do that. Now I'm going to go to stat. I'm going to go to tests, and I'm going to go to two-sample t-test. Whenever we do anything involving the mean, we use a t-test. Since we're working with two samples, we will use a two-sample t-test. We have raw data we are working with. We have two lists right here. We go all the way down. We say pooled, no. and we hit calculate. Oh, just a special mention here. Mean 1 is not equal to mean 2 is the same as our alternative hypothesis. So that's good as well. We hit calculate. And here is our p-value, about 0.006. That is a very small p-value. So here's how we interpret our result. If there were no difference in mean prices, a difference this large would occur only 6 times in 1,000. So if our null hypothesis were true, what are the odds that we got a difference as big as this? 0.006. That's what the p-value means. So that is too rare to believe. I reject the null hypothesis, so says our textbook. There is evidence that people would not offer friends and strangers the same average amount used for a camera. By the way, it appears they'd offer a friend more. All right, and maybe that's true for similar items, but that is for a different study. So there is a significant difference, and people are offering their friends a bit more, which makes sense. You want to be nice to a friend. We're going to look at another example about performing a two-sample test for the difference of means. Many office coffee stations, so says our textbook, collect voluntary payments for the food consumed. Researchers at the University of Newcastle upon Tyne performed an experiment to see whether the image of eyes watching would change employee behavior. Very interesting things going on in the north of England. They alternated pictures seen here of eyes looking at viewers with pictures of flowers each week on the cupboard behind the, quote, honesty box. They measured the consumption of milk to approximate the amount of food consumed and recorded the contributions in pounds each week per liter of milk. The table summarizes their results. And here's the big question. Do these results provide evidence that there really is a difference in honesty even when it's only photographs of eyes that are watching and not actually the good people of Newcastle upon Tyne? So here are our data. We have sample sizes of 5 pictures involving eyes and 5 pictures involving flowers, and we have a mean amount of money in pounds collected in each case and standard deviation among the cases. So let's check off some conditions and assumptions before we go on. We have the independent groups assumption. The same workers were recorded each week, but week-to-week independence is plausible. Fine, fair enough. We'll just take our results with a grain of salt, I guess. We can more or less assume independence. The amount paid by one person should be independent of the amount paid by others. Again, we're kind of making big assumptions here. We can check for randomization. The study was observational. Treatments alternated a week at a time and were applied to the same group of office workers. So I guess there is some extent of randomization. Again, we're taking our results with a grain of salt. You may have noticed the 10% condition is missing. Well, if you notice, those sample sizes were 5 each. For very small samples, just like I've mentioned before, it is okay to ignore the 10% condition. Nearly normal condition. This is the most suspect condition that we are checking here. I don't have data to check, but it seems unlikely there would be outliers in either group. No coffee hogs here. I don't think. I guess I'm not working in this office. I would definitely be an outlier in terms of coffee consumed, but yeah, anyway, I could be more certain if I could see histograms for both groups. Okay, so we are rather limited in our ability to check assumptions and conditions here, but the show must go on. We will take our results with a grain of salt, as I have mentioned. All right, to the calculator. Okay, it's calculator time yet again. Let's go to stat, let's go to tests, and we're going to go to two-sample t-test. All right, it's a two-sample test for the population mean, when difference of means, that is. And whenever we're working with one mean or a difference of means, we use a t-test, right? So we are given statistics for a change. That's nice, not raw data. And we'll need to update some things here. Notice we start with our sample mean. So we're going to do the sample involving the eyes, all right? The pictures involving the eyes. So there was a mean of 0.417, and we have a standard deviation of 0.1811, all right, and a sample size of 5. And my second sample had a mean of 0.151 and a standard deviation of 0.067, there we go, and a sample size of 5. And we are just looking for a difference here, and we are selecting no for the pooled, and we are going to hit calculate. And here is our p-value, 0.03. That's a pretty small p-value, all right? And that's going to help us interpret our results. So how do we summarize our results? Now there's a caveat. We need to assume the data were in fact free of outliers. Otherwise, there's just too much that we don't know, and this is really not a good study. But assuming the data were free of outliers, the low p-value leads me to reject the null hypothesis. This study does provide evidence that people will leave higher average voluntary payments for food if pictures of eyes are watching. Now, technically, we were trying to find if there is a difference in honesty. So technically what we found is that there is a difference between when we're using the eyes and when we're using the flowers. However, you will notice that the mean for the eyes watching is greater than that of the flowers. So that is a reasonable conclusion to make, though technically, according to the alternative hypothesis that we were testing, there is in fact a difference. That is what we found. But the difference is, it's true, in favor of the eyes, and that's why our textbook leaves the answer that it does, right? So technically we found that there is a difference in some way, shape, or form, but the difference does, in fact, favor the eyes as opposed to the flowers. Interesting study there from the north of England. So let's talk about what pooled means. You may be wondering, why do we always select no for pooled? Well, let me give you some insight as to why. If you really don't care, you can feel free to skip ahead to the section about how to interpret computer data for 2 sample t-intervals and 2 sample t-tests for a difference of population means. That's at the very end of the video. But since you're here, let's talk about what pooled means. So when we assume that 2 populations we're studying have about equal variance, we can do what's called pool the variance, which means we consider the 2 samples that we are using for our study as one big sample that's better at estimating the true population variance for the combined populations. However, in order to do that, in order to increase our sample size, which adds a bit of potency to our hypothesis test or confidence interval, we need to actually show that the populations we're studying have about equal variance, which means we need to do something called an F-test. That is beyond the scope of the course. We do talk about this in the other statistics course. So once your counterparts get to the section on t-test for a difference of means, t-intervals for a difference of means, you can feel free to chat it up with them and they will give you some insight. Here's the bottom line though. Pooling is nice, it's never necessary. It also relies on an assumption of nearly equal variance between the 2 populations. They need to be equal enough, which we can show with an F-test, but that's beyond the scope of the course, so you don't need to worry about that. So let's talk about an additional topic. We're going to interpret computer output for a confidence interval for the difference between 2 means, all right? So this up top here specifies the confidence level. We have the 2 groups right here. We have an observed difference in means. All right, so we have mean 1 minus mean 2. What is our sample mean difference? All right, this is not just a sample mean. This is the difference of the sample means, mean 1 minus mean 2. And then we have standard error, so we have a measurement of spread as well.
Um, remember that really wild degrees of freedom formula that I mentioned that is really frightening and could give you nightmares? Yeah, this is the number of degrees of freedom that this study would have. All right. And yeah, if you could imagine a weird decimal number of degrees of freedom right here, you can probably imagine how messy the formula is to get it. All right, so here's our confidence level. We have a lower limit and an upper limit, and there you go. There's our confidence interval. And just one more detail here. Without pooled variances, remember when your software or your calculator asks you if you want to pool variances, for ours it would be the calculator, just say no, we're not going to pool the variances. All right, so hypothesis test results. We have mean sub 1 for our two sample t test here. Okay, so we're going to be testing hypotheses in this. Mean sub 1, the mean of generic versus the mean of brand name. All right, so this has to do with the generic versus brand name problem involving the batteries we talked about earlier in this chapter. We have the mean difference going on here. Null hypothesis, alternative hypothesis, same kind of format that we use. Don't pull the variance. Again, we have an observed difference in sample means, measure of spread. We have wild degrees of freedom. And then you have a test statistic. Just like the calculator, we have an output of the test statistic, all right? And that's good to have, especially in free response problems or some multiple choice problems, a test statistic for a hypothesis test. But the real hero here is, of course, the p-value, all right? You have the p-value right there, and that is what is most important. Okay, so what's also important is that you handle this homework. Have a great time. Peace.